Okay, everyone, here we go. Calculus, lesson 4.5, integration by substitution. So this is a tricky lesson. You're going to have to pay close attention to the videos. I'm going to have to make a bunch of different ones, probably at least 3 or 4 for this lesson, because I want to try to keep them short because they'll take a while to upload if they're long. So integration by substitution, also called U-Substitution. That letter U is going to be important because we're going to be substituting in this new variable u into our integrals and swapping out the x terms. And we're going to create an integral full of u terms. Okay, so far we only know how to integrate polynomials and trig functions. That's all we know how to do integrals for. More complex functions we do not yet know how to do integrals for. So we're going to use a substitution method to tackle more complex integrals. Here's a Khan Academy video that is very helpful. You should watch it. Okay, here are the steps to U substitution. You set U equal to the higher order part of the integral. Whatever expression has the higher exponent, that's what order means, it's the exponent. Whichever part has the higher order, you set that equal to U. Then you want to find the derivative of u, and that is du. Derivative of u is du. Then we're going to rewrite our integral. We're going to take out all the x variables and swap back in u's and du's. And we're going to take out the x and dx. Then we're going to do the integral of u, and then finally at the very end you swap out the u's and put back in the x's. Okay, that's pretty confusing, so let's try an example. So the higher order part, well, first off, you could see this integral is composed of 2 distinct parts, right? That part and that part. The higher order part is the thing with the higher exponent. So the first thing is going to be our higher order part. That is what we're going to set u equal to. So u equals x squared plus 1. Now, after we set u equal to an expression of x's, what we want to do is find the derivative of u, aka du. So the derivative of x squared is 2x. And now whenever we do derivatives here of x's, we have to write dx along with it. Okay? Remember that when we did integrals or derivatives back a few months ago when we had a sign of dx anytime or a dy anytime we took an integral. So whenever we take a derivative of x with respect to u, whenever we do a derivative of u with respect to x, we have to tack on this dx thing to it. Okay, so now we have our u and our du. So this thing right here is u, and then 2x dx, well, that's really our du. That's what we just found out here, that du equals 2x dx. So this integral, if we rewrite it in terms of u and du, it's really u to the second power. See that little 2 exponent there? That's still there. That didn't go away. This integral becomes u squared du. Now that's an easy integral. We know how to do the integral of something being squared, right? That's just u to the third power over 3 plus c. That's our integral of u squared du. It becomes u to the third over 3 plus c. And then finally, the last step is when we write our final answer, we take out the u expression, we put back in the x expression. So instead of u to the third, instead of u to the third power over 3, we're going to write x squared plus 1 to the third power over 3 plus c. And that is our integration by parts. Okay? I'm sorry, that is our integration by u substitution. So there you have it. That is integration by u sub. We'll stop this video now and we'll try example 2 in the next video.